Okay, guys. Now we are on analyzing a time versus position graph with two objects. So now there's two objects on the graph. All right. So this says two cyclists are riding in a bicycle race. Their motion is represented by the time versus position graph below. All right. So this graph shows you my bicycle race. I've got time down here. I've got position in meters here, and then I've got cyclist A and I've got cyclist B. So two different lines. Describe the starting locations of both, so I'm on A here. Describe the starting locations of both A and B. So I'm going to say something like, um, well, so first off, let's say, so we see that B starts here at 0. So I'm going to say that B starts at 0, but A starts ahead of B. So like, we know that B starts at 0, but A is going to start a little bit out ahead. We don't know. I know you're tempted to say like, well, A starts at 2, but we don't know how this is scaled. There's no numbers on it. So let's not say that A starts at 2. Let's just say that A starts ahead of B. Okay, so describe which direction both A and B are traveling. Well, this one's pretty easy, okay? Because we see that B's position is getting bigger. A's position is also getting bigger, okay? So both A and B are traveling, we'll call this away from 0, okay? So they're traveling the same direction and they're both getting farther away from 0. Are the cyclists speeding up, slowing down, or keeping the same speed? How do you know? Okay. Well, this one can be a little tricky because we see that uphill and we automatically think, oh, well, they're speeding up. Look at their lines are going uphill. Remember, this is not velocity. This is position, okay? So remember that in a position versus time graph, if my lines are straight, not flat, but straight, then I have constant velocity, okay? So I'm going to say keeping the same speed, and it says, how do I know? Well, how do I know is because the lines are straight. All right? Which cyclist is riding faster? Okay, this is easy. We should all know this one. Remember that speed comes from the steepness. B is clearly steeper, okay? So B is faster. So I'm going to say B is faster. Then it says, how do you know? So I'm going to say its line is steeper. Okay, draw motion diagrams for both cyclists. Okay, so I'm going to draw one motion diagram, and I'm going to put both cyclists on it. So let's draw B first. Okay, so B starts at 0, and then he goes pretty fast. All right, so we'll start it at 0, and then let's go like about that fast. Remember, I got to have dots that are evenly spaced because he's going the same speed, and I have to have arrows that show that he's going away from 0. Okay, now we know that A starts off a little bit ahead. So let's start, so this is B. Let's start A off a little bit ahead. Okay, but he's not going to go as fast. So his dots are closer together. Remember, closer together dots are slower, farther apart dots are faster. Okay, so there's our motion diagram. All right, remember, if you have questions, you got to raise your hand and ask me. I can help with anything, okay, but I can't help if you don't ask. And now it's time for you to try this one on your own without my video help. Good luck.